A very good morning, all of you. Welcome back to Verilog Gate Level Modeling lecture series. In today's lecture, we are going to see how to model the universal gates as well as EXOR and EXNOR gates. Let's directly go into the Xilinx Vivado simulation window to see the code for the universal gates as well as EXNOR and EXOR gates. As you can see here, so I define my module name as universal with A and B are inputs and C and D are outputs. And you can see here my NAND gate is defined here. This directly you can use NAND primitive to instantiate NAND gate here. Your C is the NAND gate output and D is your NOR gate outputs. So let's see the RTL schematic of this code. So this is the RTL schematic generated by the simulator. As you can see here, the first one is a NAND gate and followed by NOT, and second one is the OR followed by NOT gate. Now let's run the behavioral simulation to check the all possible input combination for these NAND and NOR gates. Now this is a simulation window where I am going to keep my A as a clock signal so that I can test all possible combinations of A and B. So I'm going to run for 500 nanoseconds. As you can see here, at when both A and B are 0, 0, your NAND and NOR both producing 1, 1 as expected. 1 plus 1 will 0 plus 0 will be 0, 0 bar will be 1, 0 into 0 will be 0, 0 bar will be 1. Similarly, when both are 1, 1, as you can see here, when both are 1, 1, 1 into 1 will be 1, 1 bar will be 0, and 1 plus 1 will be 1, 1 bar will be 0. So it is very clear that your NAND and NOR gates are working properly. So this is all for universal gate simulation using Xilinx Vivado. Now we'll see the EXOR and EXNOR gate code. As you can see here, this is a code for the EXOR and EXNOR gate. You can directly instantiate EXOR and EXNOR gate using the primitive EXOR and EXNOR. And here also A and B are my input, C and D are my output. C is EXOR gate in output and D is EXNOR gate output. Let's see the RTL schematic before going into the simulation. So this is the RTL schematic. So first it is EXOR followed with a direct output of C, that is EXOR output, and followed with a NOT gate, that will be EXNOR gate. So let's run the behavioral simulation. Now let us see the simulation of your EXOR and EXNOR gates. So let me define my A with a clock so that I can test all possible combination of EXOR and EXNOR. So let me run the simulation for 500 nanoseconds. Now you can see from the simulation results, when both are 0, 0, your EXNOR gate, which is D output, is giving output 1, and your EXOR is giving output 0. Similarly, when both are 1, 1, your EXNOR again producing output 1 and your EXOR is producing 0. That means your EXNOR gate producing output whenever both inputs are equal. So we can use it as a equality detector, whereas your EXOR gate is producing output 1 whenever inputs are not equal, 0, 1 and 1, 0. So we can use EXOR gate as inequality detector. So this is how we can verify the working of your EXOR and EXNOR gate using Xilinx Vivado. Thank you all.